Hello.
Hello.
How are you?
I'm fine, thanks. Like you can hear me.
Yeah. I'll kind of explain what we have going on. I have a series of GT students who are in charge of doing a research project, and they work on it the whole year and come up with a product at the end of the year. And we like using Nepris to connect and to people to have as a primary source. And I've done a couple of these sessions already this year. And what's kind of worked best for us is kind of like a question and answer type format, if that's okay with you.
Sure.
And so this is my student here. Or what your name? Alexis. So he's just gonna ask questions and have a good conversation, and then we'll kind of go from there.
Okay. And your name again is Noah?
Yes.
And the student?
It's Alexis.
Alexis. Okay.
Hello. How old were you when you retired from working?
Well, I'm 68 years old. I retired 2 years ago. I've been working in the nuclear power industry for more than 40 years.
What were the suits called that protect from radiation?
I don't know. I never wore one. Hazmat suits, I guess. I don't know.
Hazmat?
I don't know really. I'm just guessing.
Oh, okay. What would be the difference between atomic bombs that were used in the U.S. during the World War or the war and now?
There were two bombs used in World War II, and one of them was a uranium bomb called Little Boy.
Mm-hmm. And Fat Man.
And Fat Man, that's right. The first bomb, the Little Boy, was a uranium bomb that was exploded in Hiroshima, produced about 15 kilotons of explosive. And the Fat Man was a plutonium bomb that exploded over Nagasaki, and that was about 20 or 21 kilotons. Today, the bombs are not, well, they're much bigger in terms of explosive yield, but they're much smaller too. If you were to take a modern warhead today, it'd be about the size of one of those orange traffic cones you see in the street.
Mm-hmm.
And a typical intercontinental ballistic missile might have about 20 of those. And they could produce, they would be maybe I'd say about 10 times as efficient. They would be probably on the order of about 100 or 200 kilotons each.
What do atomic bombs, what do you think they would look like in the future?
You're asking me to guess. I would say, well, there are two kinds of atomic bombs. You have the kind that we just talked about, and then there are also tactical atomic bombs, and they were developed for use on the battlefield. There was a famous system called the Davy Crockett, which was basically an artillery piece, and it had an atomic shell. And that was used by the Army, except it was never used. I think it was abandoned because they were afraid that the people firing this weapon would themselves be killed. So there are the tactical weapons, there are the strategic weapons, and then you also have the suitcase bombs. I really don't know how they're going to develop from there. They did develop H-bombs, which were much, much bigger, but they're not of much use. They got to the point where the H-bombs were so big they just weren't practical. The biggest one I think that was exploded was by the Soviets, and that was about 50 megatons, and it produced a huge explosion, and I think everyone decided, the Americans and the Soviets both, that these were just too big for practical use.
Like you said, in World War II, there was the uranium and the plutonium bombs. What would happen if you used an atomic bomb that used both?
Okay, so
Bomb that used both? Well, actually, the H-bomb does use both. You trigger an H-bomb by first exploding an atomic bomb.
yes.
And it's a small atomic bomb that gets the fusion process started. The fusion process is more like a burning fire than an explosive, and it burns deuterium, which is an isotope of hydrogen, and you can make an H bomb basically as big as you want, depending upon how much deuterium you load into it. So yeah, the H bomb is actually starts out as an atomic bomb.
The Tassar bomba was the largest atomic bomb recorded in history. Has there been any that have been larger than that?
Which bomb was that? Did you
The
mention?
Tassar, the one that you said was made out of the Soviets?
Yeah, that was it. That was the biggest one. It was about 50 megatons.
Which is the country with the most nuclear weapons?
That shifts back and forth. It was between the Soviet Union and the United States. And the number was, I think at one point was as high as 20,000 warheads. It was way more than you really needed. And I think both countries agreed to reduce their stockpile of nuclear weapons. That was called the START Treaty, and before that was the SALT Treaty. And they still have a lot of weapons, and I don't know which one has more. The point is that both the Soviet Union and the United States have more warheads than they need to destroy each other.
Do atomic bombs affect the economy largely, or do the countries have enough money to produce them?
Well, it depends. If you're an advanced country like the U.S. or Russia, it's not a huge economic burden to produce these. If you're a country like Iran, which is still trying to produce enough enriched uranium to build its first weapon, that's an enormous cost. So the answer to your question is yes and no. It could be a big economic burden. It's a good question, especially for a country like Iran. But we saw India and Pakistan produce atomic weapons, and they didn't seem to have much trouble doing it. And Israel has a stockpile of, I think, of about 200 warheads. And North Korea is still struggling to get one that works. And they've had a few tests that were not very successful.
How long can the blast, or how far can the blast radius of an atomic bomb be? Like in radius, the shock waves and stuff?
Well, we have some numbers from Hiroshima. And let's see, the atomic bomb in Hiroshima, which was only about 15 kilotons, was felt 37 miles away. If you were within about 5 or 10 miles of the impact, you were dead. The temperature around the center where the explosion occurred was about 1 million degrees Celsius.
If World War III were to happen, do you believe it would be a nuclear war?
That's really outside my field. That's policy. I'm an engineer. The World War, I think it depends on how you can't really predict a war. There's the famous general who said you can have the most detailed plans for a war, and after the first shot is fired, all the plans are garbage. Things change so quickly during a war. Right now, I would say the United States has some very, very sophisticated, smart weapons. And really, the U.S. and probably the Russians, I probably include in the same category. They don't really need atomic weapons. Atomic weapons are best. The best purpose for atomic weapons is as a deterrent. The best use for atomic weapons is not using them. It's knowing that the other side has them, and if you use them, you're both going to die. But with these smart weapons that we've seen used in places like Syria and Iraq, that target, they can target a window in a building. With that kind of accuracy, you don't really need atomic weapons. So the atomic weapons would be probably a last resort. If you know you're going to die, you might use one, and I don't know why you would do it. All that would do would be kill both sides. So my answer to your question is
Because
World War III, nobody knows what would happen. And if it ever gets to atomic weapons, that's the end of civilization as we know it. And I don't think either side wants to do that.
How does radiation affect the environment where the atomic bomb exploded? And could there be a possibility that someone could survive it?
Well, it depends on how far you are from the blast. There are survivors of Hiroshima. And if you look at Hiroshima today, it's a thriving, bustling city. It's been rebuilt. But Hiroshima, the blast itself killed about between 40 and 80,000 people immediately, and another 40,000 died later of radiation sickness. But it all depends on where they were, how close they were to the blast.
How often are atomic bombs used, like tested?
Tested? Oh, well, they're not tested anymore. There's a test ban treaty in place. But the United States, when it was developing atomic weapons, they had hundreds of tests. The first test, the most famous test, is on Trinity site in July 16, 1945, where they tested a plutonium bomb before using it on Nagasaki.
What was the Manhattan Project all about?
It was the development of a nuclear weapon. The Manhattan Project was named after the Manhattan District. It was an engineering district. Army Corps of Engineers used that name. It was led by General Leslie Groves, and it was about developing an atomic weapon. And if you want to read about how that was done, it was remarkable. It was a tremendous management accomplishment, because actually the United States developed two weapons at the same time, the uranium bomb and the plutonium bomb. And at the same time, the Germans were working on an atomic bomb, and the Japanese were working on an atomic bomb. But the whole story is in this book. It's the story of the Manhattan Project. Can you see this? Mm-hmm. It was written by Leslie Groves. I think that's better. Yeah. It says, "Now it can be told, the story of the Manhattan Project." And it's written by Leslie Groves, and there's an introduction in here by Edward Teller, who was the person behind the development of the H-bomb.
Was the United States the creator or the inventor of the atomic bombs, or had other countries had the idea before them?
Well, it's hard to say who had the idea. I would say the idea, if you want to pin it down, it was Albert Einstein. He wrote a letter in August 1939 to Franklin Roosevelt. And he said, based upon research that was done by people like Leo Szilard, it was possible to fission uranium atoms, and he thought that this would produce a tremendous amount of energy, and it could be developed further into an atomic bomb. And that was in 1939, and Franklin Roosevelt picked up on it, and like within a year, I would say, he had the Manhattan Project started.
How exactly does an atomic bomb explode?
Basically, it is a mechanism where you create a critical mass, either uranium or plutonium, and you create this critical mass very very quickly. And you have so much fissioning going on in such a short period of time that it just explodes. I mean, there's no way to control this fissioning. You create neutrons which fission more uranium atoms or plutonium atoms, depending on the type of bomb you have. The key there is to have this critical mass created very, very quickly, like in milliseconds. If you take too long to put this mass together, then it fizzles, and that's what's been happening with North Korea. You get an explosion, but it's not what you would expect in an explosion. So, for example, the Little Boy bomb, a uranium bomb, it was a gun-type bomb, which was basically a cylinder of uranium that had a little conical section cut out of it on one end. And this conical section was off on the other side of the bomb, and you had some cordite behind it. And you lit off the cordite and would push this little conical section, just shoot it into the cylinder of uranium to complete the cylinder. And so that was the missing section. And now all of a sudden you had a critical mass, and then that exploded. That's why it was called a gun bomb.
Did they calculate the amount of uranium or plutonium that they put in the bomb, or did they just like put a certain amount?
No. They calculated it. That was one of the toughest calculations. Yeah. I have pictures of the core of the plutonium bomb that they tested at Trinity. They were moving it. They drove it over to the test site in a car, and they took it out and put it into the bomb. And that core, the plutonium they used in that bomb was about the size of a grapefruit.
I think you answered his questions really well, and he's excited. I know he was very into the conversation, so I know Nepris will send us a copy of this so he can reference it later. We do appreciate your time. We know it's precious, and this is just an awesome opportunity for our students, and we're extremely thankful.
Well, thank you. I was glad to do it, and those are good questions. And if you need any more information, schedule another session.
All right. Thank you so much. Have a
Okay.
good weekend.
Bye.
Thank
Bye.
you.
Bye.
Bye.